Welcome, geometry students. Today we're going to learn about two different targets. The first is to determine and calculate the area of triangles and regular polygons, and the other is to determine and calculate area of quadrilaterals and composite figures. When we look at Unit 4, it's all about the area and perimeter of various figures. So we're going to start with very basic figures and then work on to more complex figures as we move along. Let's start with the area of a square. The area of a square equals the side squared. And we would write that formula as A equals S squared. One thing I want you to keep in mind is all formulas should have an equation. So you don't want to, for example, just put S squared. You want to include all of it, including the A equals S squared, so that when we have more advanced problems, we can solve the entire equation when needed. So keep in mind a square has 4 right angles and 4 congruent sides. So since all 4 sides are congruent, we just have to multiply one side by the other, which ends up being, rather than S times S, we write that as S squared. The area of a rectangle is equal to the product of the base and height. So we write that formula as A equals base times height. And again, we're dealing with a rectangle, so keep in mind the properties we learned last unit about a rectangle. We're multiplying the base with the height. The area of a parallelogram may be new to you. So we're calculating the area of a parallelogram. It equals the product. Keep in mind product means to multiply of the base and height. So our parallelogram looks like this. And essentially what we're going to do is multiply the base with the height. Now I want you to keep in mind this formula is the exact same formula as when you calculate the area of a rectangle, and yet they're different shapes. One thing I want you to keep in mind is when you're calculating the area of any figure and you're dealing with a height, the height has to make a right angle or be perpendicular to the base. That's really important. So if we look here, for example, this length, that's a slant height. So we could not put this length into the formula. That would not work. But we do need to use instead the right angle height. So just keep in mind the height is the perpendicular distance between the bases. So this is one example of a height. Another example would be, for example, right here. That is also a height. It's in a different location, but it's the perpendicular distance between the two bases. We also call that the altitude, so keep that in mind. Now the other reason why this formula is the same as the formula for the area of a rectangle is this little triangle. If I cut that off and move it over here, then essentially what I have is a rectangle. So that's why it works to use the same formula. Example 1, find the area of a parallelogram. Well, it's parallelogram PQRS. So the first thing you're going to do for all of your problems, even if it seems like a very basic problem that you could do quickly using mental math, is you're going to write the formula. That way, if you make a mistake on picking which formula to use, I know what's causing the mistake. Maybe it's the formula is incorrect, or maybe it's something else, but that'll help me to figure out what your mistake is a little bit easier. Now looking at this picture, there's a lot of lengths. Well, there's 2 bases that we could use. We could use the side length of 12, or we could use the side length of 6. So take your pick. I'm going to show both methods. If I use the side length 12, then that's the base. And then the height has to make a perpendicular with that base. So in this case, the length that makes a perpendicular would be 4. So the area of the parallelogram is 48, and the units on any area would be units squared. So anytime you're calculating an area, you would have units such as feet squared, meters squared, and so forth. Now let's look, what if we had used the other side length, in this case PS? We're still using the same formula because it's still a parallelogram. So I would do area equals base times height. It's important that you show that for each problem. Then the base would be 6 because that's the side length. But if you notice, our height can't make a perpendicular between the bases inside the figure, but it's going to make a perpendicular on the exterior of the figure. So the height in this case that would be perpendicular if we extend that base would be 8. And if you notice, 6 times 8 is 48 units squared. So it doesn't matter which base you use, you get the same answer. So obviously you don't need to do the problem twice, but I just wanted you to be aware that you could calculate it in 2 different ways for this particular problem. All right, the area of a triangle is equal to half the product of the base and height. Be careful not to forget about that half. So our formula is A equals 1/2 base times height. Some of you might have heard this as area equals base times height divided by 2. They mean to do the exact same thing, so it's just a difference in how you show your operation. Keep in mind we're dealing with a triangle. Could be acute, could be isosceles, could be a right triangle. It doesn't matter. The big deal is that the base is going to be one of the side lengths, and then the height has to make a perpendicular with the base. So we would do 1/2 the base times the height for the area of a triangle. All right, let's look at example 2. Example 2 says to solve for unknown measures. We're not going to be given a picture for this problem, so I would highly recommend, if you would like a visual, to draw the picture. It says the base of a triangle is twice its height. So we need to draw on our height, knowing that that's going to make a perpendicular with the base. It says the base is twice as long as the height. So we need to know that the height is h, or x, and then the base is going to be double that. So we would say 2 times h. Then we need to know that the area of the triangle is 36 square inches. So this is another important fact. Find the base and find the height. So this is a situation where we're going to use the known area to find other unknown information. We're going to use the same formula as we would if we were finding the area of this figure. Area equals 1/2 base times height. Now earlier I mentioned you want to make sure your formulas are equations, meaning that you put the A equals when you write your formula, because that gives us a little more opportunity to use that formula. Now it's telling us that the area of the triangle is 36 square inches. So in our 3 variables, A, B, and H in this formula, we know that the area is the same as 36. We also identified from our picture that the base is twice H. So the base is 2H, and the height is what we called H. So I'm just taking my information from my picture. Now what we have to do is solve this formula for H. So we have 36 equals, well, 1/2 times 2, those are going to multiply to be 1. And then H times H, be careful, is not 2H. H plus H is 2H. But H times H is H squared. So now we need to consider how we would solve this equation for H. Well, think back to Pythagorean theorem. If we need to undo a square, we use the opposite, which is to square root. Keep in mind that when you solve this, it could be plus or minus 6. When you take the square root of a variable, it could be plus or minus 6. But because this is a height, really we know the height to be a positive length, not a negative, so this would be a length of 6 units, specifically inches. So be careful, we're not quite done yet. It does say to find the base and the height. We already found the height, now we need to calculate the base. Well, if you notice, we said that the base was 2 times h. So since we already know h to be 6, we can calculate the base to be 12 inches. Now, if you're in doubt whether you did this problem correctly, you can quickly check it by using what we just calculated. We know the area of a triangle is 1/2 base times height. So the area equals 1/2. The base we calculated to be 12, and the height we calculated to be 6. Well, 1/2 times 12 would make that 6, times another 6 would make it 36 inches squared, which checks our work that we've done this correctly because the area came out correctly. Example 3. You need to buy paint so that you can paint the side of a barn. The gallon of paint covers 350 square feet. How many gallons should you purchase? Well, if we look at this, we're only painting this one particular side of the barn. So we have two figures making up the side. We have a triangle, specifically a right triangle, and we have a rectangle. So our job is to figure out the area of the side of the barn and then decide how much paint we're going to need. Well, this is what we call a composite figure. We don't have a way to calculate the area of this entire shape at once, so we're going to divide it into two different shapes. Like I said, a right triangle and a rectangle. So let's start by calculating the area of the right triangle. There are a couple different ways that you could approach this, but the easiest way, in my opinion, would be to consider the base and height right here around the right angle. So keep in mind, in a right triangle, the base and the height will actually be two side lengths, whereas in other types of triangles, it may not be a side length forming the height. So we don't know either of these lengths, but we do know by these markings that they're both the same measure. So what I'm going to do is use Pythagorean theorem to calculate x. So a squared plus b squared is equal to c squared. Well, if I look at this, the two legs of the triangle are x squared. So x squared plus x squared is equal to 26 squared, which is the hypotenuse. So now we have to do a little bit of algebra here. X squared plus x squared, keep in mind there's a coefficient of 1 for each of those. So if we were to add those, we get 2x squared equals 26 squared comes out to be 676. So our equation says 2x squared equals 676. Okay, I just moved this over so I had a little bit more room to solve my equation. So now what we need to do is divide by 2 to remove the coefficient of x squared. Well, 676 divided by 2 is 338. Keep in mind, if you have any questions on the algebra involved here, there's some pretty challenging algebra going on if you're not used to working with x squared and so forth in your equation. So if you have questions about that, please make a note in your annotation so we can discuss that. Now we're going to go ahead and solve this by taking the square root, since that's how we undo a squared. So we find that x is equal to the square root of 338. If we try to simplify this to be simplified radical form, we're going to find that it is not going to come out to be simplified. So we're just going to leave x as the square root of 338, or you could make it a decimal if you'd like. I'm going to keep it the exact form just so it's more exact and more accurate. Okay, so I found the two side lengths of that right triangle. I still have not calculated its area, so now let's go ahead and do that. Area of a triangle is 1/2 base times height. So I would do 1/2. Keep in mind the base and the height have to form a right angle with one another. They have to be perpendicular. So this essentially is the base, and this is the height. So we have 1/2 times the square root of 338 times the square root of 338. So the area of the triangle is equal to 1/2, and then if I look at this piece here, square root of 338 times the square root of 338 is going to be simply 338. The reason being is they're the same square root, so basically the square and the square root are canceling out there. Therefore, the area of the triangle is 169 units squared. So we found one part of our figure. Now we need to find the area of the rectangle. You're going to find that this is a much simpler process. So area of part 2, in this case the rectangle, is base times height. The base and the height are 18 and 26. So the area of that is going to be 468 units squared. Now if you notice, I marked on my picture area of 1 and 2, meaning I numbered the different shapes. I also marked when I found the area, I labeled it as area 1 and area 2. I just used a subscript to identify which area I was calculating. So now the total area is equal to the sum of these two areas. So 169 added with 468. So the total area for this entire side of the barn is 637 units squared. I'm almost done. I still need to decide how much paint do I need. So since each gallon of paint covers 350 square feet, and I have 637 square feet, I'm going to calculate that by doing 637, the amount of square feet I need to cover, divided by 350, the amount of paint that is covered by 1 gallon, and we come out to get an answer of about 1.82. Well, since I can't go to the store and purchase 1.82 gallons, I need to round up and say that I need 2 gallons of paint. Now clearly this problem is much more involved than some of the other more basic problems we saw today. So this is where we need to end up, at these multi-step problems. Just take your time while you're working through these, and eventually you'll get the process down and they'll go more smoothly. So just keep practicing these as they come up. Go ahead and try the You Try Now. There are 4 problems. Just be careful while you're working them that when you're calculating a height, that it has to be a perpendicular height, not a slant height. Have a good day.